Good morning, crew. Let's continue with rate laws. I'm on worksheet 5. I'm looking at number 3. I just posted the key to number 2. That was homework yesterday. So if you look at number 3, it's basically number 1 in reverse. Instead of going from HI to H2 and I2, it's the reverse reaction. That's fine, but now we have, in this instance, two reactants. Okay, so my rate law would take the general form of rate equals K times H2 to some order times the concentration of I2 to some order. So here's my data. And what I'm going to do is I'm going to try to scan the data and look for a series of experiments, two experiments, in which only one factor is changed. If only one factor, only one concentration of reactant changes, then I can determine the rate change and surmise the order for just that factor. So look for something where only one variable changes. Okay, so in experiments 1 and 2, only I2 changes. I didn't change H2, but I did change I2. So I can use those two experiments to figure out the effect that I2 has on the rate. And if I look at experiments 2 and 3, only H2 changes, so I can figure out the order with respect to hydrogen based on that. So here's the first couple. Here's experiment 1 and 2. I'm leaving hydrogen alone. I doubled I2. My rate doubled. That's a match. I2 is first order. So I could go back here and I could put a 1 there. Then I go to my next experiment and I say, all right, well, in experiments 2 and 3, I left I2 alone and I doubled H2. Oh, and my rate also doubled. Okay, so H2 is also first order. So I can go back here and say, all right, well, that one's first order. So there it is. First order for H2, first order for I2. First order means it's to the first power. No big deal, they drop out. I can go back to my data, pick any of the experiments, plug and chug, solve it for K. So I chose experiment 1. Rate 0.2 is equal to K times H2 times I2. Well, they're both 1. K is 0.20. Easy peasy. Okay. Well, in a well-designed series of experiments, each reactant is considered individually, while the concentration of the other reactants is held constant. So you change only one factor at a time. Sometimes, however, the series of experiments fails to account for each reactant separately, such as life. Logic can be applied to determine the order of the reactants that were not studied directly. You can still figure it out. So let's slide on over to number 5, back page. Last one on worksheet 5. So I've got nitrogen plus 3 hydrogens form 2 ammonias. Okay, right off the bat, 2 reactants, I could say my rate is K times nitrogen to some power times hydrogen to some power, and I have to determine those powers. Here's my data. I look at experiments 2 and 3. I'm leaving hydrogen alone. Nitrogen went from 2 to 8. That's a factor of 4. Also, side note, I don't want sig figs to become an issue here, so put a dot here, make this 50.0, and put a dot here so you have 3 sig figs consistently throughout the data table. Sorry about that. Once again, hydrogen doesn't change. Nitrogen goes from 2 to 8, that's a factor of 4. My rate goes from 50 to 200, that's also a factor of 4. So in experiments 2 and 3, hydrogen's held constant, N2 can be seen to be first order. Okay, so N2 is first order. And now I look for a series of experiments where I hold nitrogen constant and I look for the effect of changing hydrogen. Don't have it. All is not lost. You have enough information to figure it out. See what I mean about the phone ringing every 10 minutes? Scammers are on high alert. All right, so back to our data. In experiments 1 and 2, everything's changing. Working from 2 to 1, respectively, always worked. Very frustrating. Up. I doubled nitrogen, I doubled hydrogen, and my rate went up by a factor of 8. Consider these respectively working up. Here are my changes. Nitrogen went up by a factor of 2, hydrogen went up by a factor of 2, my rate went up by a factor of 8. I also know that nitrogen is first order. If nitrogen was the only change, the rate should be doubled. It should match. But it actually went times 8. Any leftover changes beyond doubling are the effect of the changes in hydrogen. So any changes beyond this times 2 would be the result of the changes in hydrogen. Well, so my rate should be doubled, but it is 8 times higher. Take that ratio. What is it? Divided by what should it be based on your known changes? That's a factor of 4. That's the effect of hydrogen. It's 4 times higher than it should have been based on just changing nitrogen. Oh, well, what did I do to hydrogen? Well, I doubled it. And my rate's 4 times higher that I've surmised based on taking into account what I knew? Well, that's second order. Oh, so hydrogen is second order. So you can determine the rate law. Nitrogen is first order, hydrogen is second order. There's my rate law equation. Go back to your data, plug and chug, pick any of the experiments, and solve it for K. I went to experiment 1. I said 400 is K times 4.0 to the first power times 4.00 to the second power, divided out, and I got K of 6.25. So sometimes the series of experiments doesn't take into account all of the reactants individually. That doesn't mean all is lost. It's nicer when everything's individual, but it doesn't have to be. So part of your homework tonight is going to be number 4. That's, I'll tell you right out, that's a simpler scenario, which is the only one we haven't done on this page, but worksheet 5, number 4. And we're going to go over to worksheet 6 now. I want to look at worksheet 6. I want to work on the first set of problems, numbers 1 through 3. So we've got 3 reactants, A plus 2B plus C, and 2 products, goes to D and 2E. Got a little stoichiometry there. These are hypotheticals, A, B, and C, D, and E, but that's okay. I can draw my rate law equation. 3 reactants, A, B, C. Okay, rate is K times A to some power times B to some power times C to some power. And I'm going to look for a series of experiments in which only one of the reactants changes. Hey, in my data, they told me they measured the rate of the formation of D. That's nice. In worksheet 5, they never told me what they were measuring. Here they're saying, hey, I'm measuring how fast, how quickly D is appearing. Okay, if it was A, B, or C, they'd say how fast is A or B or C disappearing. Since it's a product, they say how fast is D appearing. Okay. So right off the bat, I go, I do not have a series of experiments where B remains constant. So I know this is going to be potentially a more difficult problem. I can look right off the bat and say in experiments 1 to 2, all I did change was B, so I can figure out B from my first 2 experiments. And then if I look at experiments 2 and 3, well, no, I have at least one thing held constant there, but nothing here, nothing here. If I look at experiments 2 and 4, A is constant, yeah, but that's it. Well, let's consider them individually. Look for the most logical path first. So if I look at experiments 1 and 2, I only have one change. A is not a factor. C is not a factor. The only thing that changed was B, and I doubled B. And my rate did not change. B is 0 order. B doubled, and my rate remained the same. zero order. Put a 0 here. Now we know anything to the 0 power is 1, and anything 1 to any power, or anything to the first power, is that this is just, it's anything to the 0 power, so this drops right out. It's gone. B is not a factor. Do yourself a favor. Go back to your data table. Unclutter it. B is not a factor. I never need to look at it. I don't need to consider it. Make that big X on your column and it will help you. So now let's go to a different color here. I'm going to try and get this all on one page. I need to measure the effect of A and the effect of C. If I look at experiments 2 and 4, actually 4 to 2 respectively, here I have A not changing, but I have C doubling. So the only thing I changed going from here to here was C. What happened to my rate? Oh, it doubled. Okay, so if C is the only change, and C goes times 2, and my rate goes times 2, C is first order. Okay. Now what? I want to change only A. I want to leave C constant. Do I have a series of experiments that do that? I know it's getting cluttered here, but take a look. I have experiments 2 and 3. C remains the same, but A doubled. What happened to my rate? It went up by a factor of 4. The only change I had between experiments 2 and 3 was A. The only change in reactant concentrations. And my rate doubled. So A went times 2, and my rate went times 4. Oh, A is second order. So now I can rewrite my rate law equation and say rate equals K times A to the second power, I don't need B at all, times C to the first power, which is just C. It's a multiple choice question. So K A squared C, K A squared C, that's choice D. Now, look at the next ones. Here they're asking me about, I know this is a little bit small, but in question 2, in experiment 2, the rate of formation of E, well, I measured D. Doesn't matter, they're related through stoich. So in experiment 2, I know that D, this is experiment 2, D was forming at 2 moles per liter per minute. So I had 2 Ds forming. But they asked me about E. If I look at my stoich, if D goes down there, E goes up here, look at your coefficients, 1D, 2 E's. 1D, 2 E's, oh. E would be 4 moles per liter per minute, which looks like choice B in the multiple choice. Number 3, in experiment 3 this time, they're asking me about B. Go to experiment 3. And in experiment 3, they measured D. They said, oh, 8 Ds. Well, put D in the bottom. They're asking about B. And what's my stoich? 2 B's, 1 D. 2 B's, 1 D. that would be 16 B's, which would be choice D. So you can apply stoichiometry once you know the rate of formation or disappearance, or once you know one of the rates, you know them all. They're all related through stoich. Second part of your homework today, I want you to do the next set on worksheet 6. So you're going to do this set, numbers 4 through 10. 10 is a limiting access problem. Don't let that fool you. It's not so hard. They're asking about experiment 3 here. Look at the data for experiment 3. 0.20, 0.02, 0.08. This is 10 times higher than that. You're not going to run out of A. You don't have any coefficients of 10 here. A is going to be excess. B looks to be the lowest. C is pretty high. I'm going to guess that B is my limiting reactant. I'll leave you with that. So your homework tonight, you're going to do worksheet 5, number 4. You're going to do worksheet 6, numbers 4 to 10. All right, I'll post a key tomorrow. Take care.